While performing an experiment, you collect a sample of gas in a bottle that is immersed in 32.5 degrees Celsius. What is its temperature in kelvins? All right, there's a few things that I can remember, and there's a whole bunch of different formulas, or two formulas, that I can never remember the exact format of. But I do know two things. I do know that when I convert Celsius to Kelvin, there's a number that sticks out in my head, and it's 273.15. And there's also the whole concept of absolute zero. So that would be 0 degrees Kelvin. And so I know that absolute zero is the lowest temperature that you can get, which means you can't get any lower, which means that Kelvin can never have a negative scale. It can never be negative 5 degrees Kelvin, because once you reach zero, you have bottomed out. Whereas you can have negative 5 degrees Celsius, and sometimes it reaches that in different places. In fact, quite often it reaches that in the upper United States and different parts of the world for sure. So this 273.15, that must mean that that is the Kelvin that it would be if I was talking about 0 degrees Celsius. Okay? Because 0 degrees Celsius isn't the coldest you can get. You can get smaller than that. And so this 273.15 can always become a smaller number. But once you reach 0 Kelvin, which is actually 0 Kelvin is the same as negative 273.15 Celsius. That's what the equivalent temperature would be. So basically you're just kind of offsetting this thing. Essentially, I'm going back to this equation that I kind of have to figure out. And so let's see, if I have my temperature in Celsius and I add to that 273.15, this will give me my temperature in Kelvin. The reason why I say I always get confused is because sometimes I always mess this up. And I can't remember which formula it is. And I don't always mess it up, but I often get that messed up. And then when I sit down and think about it, and I say, well, what if I plug in 0 degrees Celsius? Then I know that that's 273 Kelvin. The only equation that really works for is this one, because when you plug a 0 into here, you end up getting 0 plus 273.15 is equal to your temperature in Kelvin. So I know that this equation down here is bogus. Anyway, all of that to tell you that here's the equation that you need. If we want the temperature in Kelvin, like the problem is asking for, then what we've got to do is we got to just take 32.50 Celsius and add to that 273.15 degrees. Let's pull out the calculator. We got 32.50 plus 273.15, and that equals 305.65. So my answer is 305.65. 305.65, and I need to put the units K. And for some reason, you have degrees Celsius and you have degrees Fahrenheit, but whenever you're dealing with Kelvin, you don't need the word degrees out in front of it. I think that's just by definition. All right, let's try the next problem. The temperature of seawater jetting from a black smoker vent on the bottom of the ocean in the mid-Atlantic ridge was measured to be 671.5 Kelvin. What is its temperature in Celsius? All right, so one of the things you have to make sure to think about is which one's bigger? Which one's always going to be measuring bigger? Is it the Kelvin or is it the Celsius? And the Kelvin will always give you a bigger number, because Kelvin is just offset. And how much bigger? Well, it's going to be exactly 273.15. That tells me that all I have to do is subtract it, but I can actually prove that to you if I take this formula again. The TK is equal to TC plus 273.15. And then this time we want the temperature in Celsius, so I just need to solve for it. I need to subtract 273.15 from both sides. and I get TC is equal to TK minus 273.15. If I plug in my numbers, they said it was 671.5 Kelvin for my temperature in Kelvin. And I'm going to take off from that 273.15, pull up the calculator again. So that's 671 minus, or sorry, 671.5 minus 273.15. And I end up getting 398.15. That's it. All right. The last one is asking me to convert 212 degrees Fahrenheit into Kelvin. Now this one's going to be a little bit trickier. And the reason being is because if I want to convert Celsius to Kelvin, there's this nice little just adding or subtracting the number 273. And I do have a formula to convert the Fahrenheit to the Celsius and vice versa. But what I don't have is a formula that goes straight from Fahrenheit to Kelvin. But here's my advantage. What I could do, and here's the plan that I'm going to go with. Let me erase this real quick so I have some room. Actually, you know what? I'm not going to erase it. I'm just going to put it at the bottom. Hopefully I have enough room. The nice trick that I would go about doing is I'm going to go from converting from Fahrenheit to Celsius because I have a formula for that. And then I'm going to convert Celsius to Kelvin because that's just a matter of adding or subtracting 273.15. Actually, in this case, it would be adding. All right, so I have my formula. My temperature in Fahrenheit is equal to 1.8 times the temperature in Celsius plus 32. And so I have Fahrenheit. I need Celsius. So let me do some algebra real quick, and I'm going to solve for TC. In order to do that, I'm going to take my TF. I'm going to minus 32 because I need to move that over to the other side. And then I'm going to divide the whole thing by 1.8. And that gets rid of that thing. All right, cool. So in order to get my temperature in Celsius, I just say, all right, well, TC is TF, which is 212.0 degrees Fahrenheit, minus 32 degrees Fahrenheit, all divided by 1.8. All right, let's see, calculator, what did it say, 212.0 minus 32 equals, all right, 180, and divide that by 1.8. So here's the divide, 1.8. And I'm looking at 100. So I have 100 degrees Celsius. Now, if I want to convert that to Kelvin, I just take my temperature in Celsius and add 273.15. And my answer is 373.15. Yeah. Now, I don't think we've taught you significant figures just yet, but as far as converting this or making sure that I do this right, essentially what I need to do is, let's see, this number right here is where I'm going to tail it off. So my answer is going to be 373.2 Kelvin, because I'm going to round or cut it off there and round up because I have a 5 to the right of it. All right, well, that's it.